Alright, so let's go through this ACJC promo question from 2022. Okay, so we have this plane P1 has the equation negative 6x, negative 4y plus 2z equal to 4. So this one is your Cartesian equation. So find a vector equation of the plane such that the perpendicular distance from each plane to P1 is about 10 units. Okay, so first I must actually convert our Cartesian to your scalar product. So means I actually put r dot negative 6, negative 4, 2, where this thing right here, right, is your normal vector is equal to 4. 4 we can actually express in terms of a dot n, where a is a position vector that is lying on the plane right here, and of course n is the normal vector. Okay, so based on this, right, I can actually convert this scalar product equation to something that we learned as well. So r dot n hat is equal to a dot n hat. So of course the n hat is the unit vector, normal vector in terms of the unit vector. Then after that, a dot n hat is actually a number because it's a dot product, so it's a number. So this value right here is actually the distance from the origin to the so-called plane, the perpendicular distance from the origin to the plane. So this itself is a dot n hat. Okay, so let's try this question. So first, we must find our n. So n, right, is negative 6, negative 4, 2. Okay, then after that, I find what is the n hat. So n hat is the unit vector. So negative 6, negative 4, 2, divide by the so-called magnitude of it. So it's 36, 16, and 4. So it's about 56. So this is the unit vector. Okay, so based on this, I also need to find one more thing, is the position vector that's lying on the so-called plane P1. Okay, how to find the position vector? This one I must go back to this part. Okay, so you look at this scalar product form, right? So we want the 4. So a dot n, right, must give me 4. But of course I know what is my n already. My n is negative 6, negative 4, and positive 2. So my position vector that I must give them, when I do the dot product, right, must be equal to 4. So this one I just do it simply is 0, 0, and 2. So because 0 times negative 6, 0 plus 0 times negative 4 plus 2 times 2, 4. So means that one of the possible position vector that I can actually conclude, right, is 0, 0, positive 2. Okay, so I already know the position vector that's lying on this plane, so I can actually do the substituting already. So let's do the substitution. So first, a 0, 0, 2. Then I dot with this 1 over square root 56. Then here is negative 6, negative 4, and positive 2. So this will give you a value of 1 over square root 56 and 2, 2, 4. So it's 4. So this will be about 4 over square root 56. Yeah, so this value right here, right, 4 over square root 56 is actually the distance from the origin to the so-called plane. So this is 4 over square root 56. Okay, then what they want us to find is the equation of two possible planes. So for example, okay, so they say, maybe I draw here as well. Okay, so this is the P1. Then after that, I know, my origin, right, to this part is 4 over square root 56. So I want to find another plane, right, that is 10 units from the so-called P1. So means, okay, let's call this maybe P2. So from here to here is 10 units. So I can actually conclude one thing is, my P2 must be parallel to P1. So means, okay, this one I can put as such. So P2, I can put R dot n hat equal to A dot n hat. Where n hat, where A dot n hat, right, you just put 4 over square root 56 plus 10 units. This one you can simplify. So n hat, okay, what about the n hat of this new plane? Because they are parallel, the two planes are parallel, means that they must have the same normal vector. So the normal vector must also be this, right? Negative 6, negative 4, and 2. So this is a normal vector because it's parallel, right? So meaning that your new plane will have this equation. So it's n hat, right? So it's 1 over, okay, so I put here 1 over square root 56, negative 6, negative 4, 2. So equal to about 4 over square root 56 plus 10. So this is the one of the answer. Of course, make it nicer by simplifying it. This thing you can move to the right hand side. So r dot negative 6, negative 4, positive 2, right, is equal to 4 over square root 56 times square root 56 is just 4 plus 10 square root 56. This one you can simplify further by using the cert thingy, right? So it's equal to 4 plus 10. Then this is 56 divided by 4 first. Okay, so it's 2 and 14. So this will give you 4 plus 20 square root 14. So this is one of the so-called vector equation. Okay, what about the second one? Okay, the second one is actually lying below. So let's just say there's one more. Okay, it's lying below. So also same thing, they must have the 10 units perpendicular distance, right? Okay, so I make use of the idea from here, right? So because our vector equation, scalar product form must be with respect to the origin. So means I need to find here to here. So this one definitely is a negative distance, right? So this one you can put r dot n hat equal to 4, so it's 4 over square root 56 minus of 10. Yeah, because this one is like a negative distance like that. So this will give you about this r dot 1 over square root 56 negative, I think it's, sorry, negative 6, negative 4, and positive 2 equal to 4 over square root 56 minus 10. And then just simplify further. So r dot negative 6, negative 4, positive 2 is equal to 4 minus 10 square root 56, which will result in the form of 4 minus 20 square root 14. Should be, yeah, correct. So this is the second one. So this second one, which is lying below, then this one is the top one lying above. Okay, so this is the first part of the question. Let's move on to the second part. Okay, second part. The plane P2 has this equation. So it's again your Cartesian equation where K is a constant. So find the angle between your P1 and P2. Okay, so this one, just remember the formula. So for example, I draw the so-called side view. So this is the first plane. This is the second plane. Okay, so of course, for the first plane, there's some normal vector. Second plane, there's also a normal vector. So the angle between, you simply just put normal, intersect. Okay, the angle between your P1, P2 is just this angle. So means you can just, for example, if I extend the normal vector right here, so here and here. So actually it's just this angle. So this one you can use cosine theta equal to n1 dot n2 over n1 n2 modulus, or the length of n2. Okay, so based on this, I just put in the thing first. So this one is r dot, I convert to your scalar product. So it's negative 1, positive 2 is equal to k. So I need the normal vector, negative 1, and 2. And of course, the first one is negative 6, negative 4, and positive 2. Yeah, so based on this, right now, negative 6, negative 4, 2. Negative 6, negative 4, positive 2, dot with negative 1, 2. Positive 2. Okay, then you do the magnitude. So the first magnitude will be about 56. Second magnitude is about 6. Okay, so this will result in the form of 6 plus 4 plus 4. over square root 56 times 6, about 336. So this will result in 14 over square root 336. So with this, right, you just find the theta. So cosine inverse 14 over square root 336 bracket. So it's about 40.2 degree. So the angle between the two planes will be about 40.2, which is this part. Okay, so with this, let's move on to the part 3. The plane P1, P2 intersect in the line L. Show that the possible vector equation of line L, right, is given to be as such. Okay, for this, right, due to the fact that we do not know what is the value of k, so I cannot use my GC already. So I must do something else. Okay, let me write down the Cartesian equation. So, okay, part 3. So the first Cartesian equation will be negative 6x minus 4y plus 2z minus 4y plus 2z is equal to positive 4. So the second Cartesian equation is given to be negative x negative y plus 2z equal to k. Okay, so how do we actually solve this so-called polynomial equation, right, if I do not know the value of k? Okay, so there's one way. We need to do substitution. So for example, you can sub z value to be 0. So this one you can also sub for x and sub for y, but apparently you look at the equation given to us, right, the z value is 0. So you sub in z equal to 0, so this will result in the equation of negative 6x minus 4y equal to 4. So that's the first equation. Okay, second equation is negative x minus y equal to positive k. So you can see we can just solve the simultaneous equation. Okay, so I solve the simultaneous equation. So this will give me something. Okay, so maybe I times 4 here. For this equation 2, right, I times 4. So this will result in negative 4x minus 4y equal to 4k. Then I use the elimination method. Equation 1 minus of equation 2. So equation 1 minus equation 2. So this will result in negative 6x negative 2x equal to 4 minus 4k. Then just get the x value. X is equal to minus 2 plus 2k. So that's the x value. Okay, what about the y value? Y value is simple. We simply just use this equation. So I sub in the x value inside the second equation. So it's negative 2 plus 2k minus y equal to k. Then I make y the subject. So y is equal to 2 minus 2k. Move the k to the left hand side, minus k. So the y value is about negative 3k plus 2. Right? Okay, so we got x and y. So of course z must be your 0. Okay, so let's take a look. Let's go back to the equation. Okay, the equation is, okay, I already get the so-called position vector of the line already. Okay, how do I actually get the so-called direction vector of the line? This one, you must use your cross product already. Because if you still remember, for example, right, okay, assuming, let's just say I got two planes, they intersect at a line. So means that the line actually lies right here. So this one is a side view. So the direction vector actually is perpendicular to this vector and this vector. So means that we must use the cross product. Okay, so the cross product will be something like this. So of course I write down the position vector first. So the line L is R equal to, okay, so the position vector is given to be negative 2 plus 2k. Then this one is 2 minus 3k. Then this one is 0. Okay, plus lambda something something. So what is the something something? You must do the cross product. So the cross product is the cross of the two normal vectors. So meaning, for example, negative 6, negative 4, 2, and negative 1, negative 1, 2. Okay, so this one is direction negative 6, negative 4, 2, cross with negative 1, negative 1, positive 2. Okay, so let's try this. Okay, for example, the first one. Okay, the first one, how to do the cross, right? Very simple. To get this, you cover up the first part. You only see this part. So you do the cross. So for example, the first one and the second one. So it's negative 4 times 2, negative 8, minus 2, negative 2. So it's minus 2. Okay, the second one, remember to add in a negative. Okay, negative, right? So first, okay, so I cancel first. Okay, so for the second one is like that, 1 and 2. So it's negative 6 times 2, negative 12, minus of 2 times negative 1 is negative 2. Okay, the third one also quite simple. So the third one I remove first. Okay, so it's cross. Okay, so the third one I cover up the third one. I do the first two, 1 and 2. So it's negative 6 times negative 1 is positive 6, minus of negative 4 times negative 1 is positive 4. So this will be the direction vector of the line. So it's negative 8 plus 2, negative 6, then negative 10. So negative, okay, so it's positive 10. Yeah, correct. So this will be positive 2. So this is the direction vector, but of course you can simplify it because negative 6, 10 and 2 actually there's some common factor. So I simplify it, I see what they actually want. Negative 3, 5 and 1. Okay. So the 1, negative 3, 5, 1. So means I can actually factorize out the 2. So 2, negative 3, 5 and positive 1. So the 2 you can just put it aside already because this one can be absorbed inside this lambda, where lambda, right, is any real value. So definitely negative 3, 5 and 1 is here. Yeah. So that is the so-called line equation. So this part, right, is the position vector. This part is the direction vector. So to get your position vector, always remember you must solve the so-called simultaneous equation. Okay, so negative 2 plus 2k, yeah, okay, 2 plus 2k, yeah, correct. Okay, so that is for part 3, quite a long part. Okay, so for the part 4, the plane P3 has the equation given to be as such, right? So 5x, again your Cartesian equation, you can convert to your scalar product, 5 beta and 5 equal to mu. Okay, so given that this line L, right, actually is contained in P3, means that the line L actually lies on the plane P3. Find what is your beta and mu, giving your answer in terms of K if necessary. Okay, let me just draw this thing out first. Okay, maybe I draw here. Okay, so for example, right, okay, this is the plane P3. Then there's a line. So this line is contained in P3, means that it lies on the line. Okay, then there's of course a normal vector. So the normal vector, you can get it by doing your conversion to your scalar product. So it's 5 beta and 5. So this is 5 beta and 5. Okay, so for this line equation, right, because we already know, my line, there's a position vector of this, and of course a direction vector of negative 3, 5 and 1. Okay, so let's determine our beta first, the easy part first. Okay, so for the direction vector, let's just say there's a direction vector, which I don't know, I just say point here. So the direction vector is negative 3, 5 and 1. Negative 3, 5 and 1. Okay, how do I actually find beta based on these two information? Right? Okay, so based on this, apparently you can see that the two vectors are perpendicular. So as long as they're perpendicular, you can try to use the dot product, because the dot product of two perpendicular vectors, right, will give you 0. Meaning, for example, okay, negative 3, 5 and 1 dot with 5 beta and 5, it will give you 0. Then you can solve for beta already. So the value of beta, right, so for the first, negative 15 plus 5 beta plus 5 will give you 0. So 5 beta minus 10 will be 0. And of course, 5 beta equal to positive 10, beta will be positive 2. So that is the value of beta. Okay, what about your value of mu? For the value of mu, you can use your position vector to help you find. So for example, because we know that mu, right, is A dot N. I already know what's my N because I know my N, right, is 5 beta. Okay, beta is beta is positive 2. Positive 2 and 5. So this one is my N. And of course I can find my A. Okay, my A will be the so-called position vector of your this, because the line actually lies on the plane. So means I can also say that this thing lies on the plane itself. So this one also can be the position vector of your plane. Okay, 2k minus 2. Okay, 2k minus 2, 2 minus 3k. Okay, 2k. So okay, I put the position vector first. 2k minus 2. 2 minus 3k. And 0. Okay, so this is a position vector. I sub inside your scalar product. Oh no, don't need. Yeah, can. So A dot n, right? So A dot n is mu 5, 2, 5. Okay. Dot 5, 2, 5. So this will give you mu. So you just do the scalar product. Of course, this one I believe might be in terms of your k. So the first one, 10k minus 10 plus 4 minus 6k plus 0 equal to mu. Then this is 4k minus 6 is equal to mu. So this will be the value of mu in terms of k. So the mu is about 4k minus 6. Hopefully I never manipulate wrongly. Okay, the last part. This one is simpler. Given that instead that line L does not intersect P3, so what can we say about the values of beta and mu? 1 mark. Okay, for this type of question, very simple. So first, okay, I withdraw my thing. Okay, so I draw the plane. So this is a same plane. So if they say that the line does not intersect, means I can safely say one thing is that these is above. And this line is so-called like parallel to the plane, meaning the direction vector will still be perpendicular to the normal vector, meaning that your beta, right, will still be 2. So the beta will never change, but something will change, right? Because the line doesn't lies on the plane, means that this value, right? So just now I actually got the mu equal to 4k minus 6. So I must say that mu is not equal to 4k minus 6. So that is how we actually do this question. Quite a long question, to be frank.